Lesson 1-7 is called Represent Functions as Rules and Tables. So up to this point we have written algebraic expressions and then we put an equal sign between two expressions and made equations. So now we're going to go ahead and represent functions as rules and as tables. So we're going to write some equations and then we're going to put them into a table. Or we're going to look at a table and then write the equation. When you pump gas, the total cost depends on the number of gallons that you pump. The more gallons that you pump, the more it's going to cost you. So the total cost is a function of the number of gallons pumped. And the definition, a function, consists of two different things. There's two parts in this first bullet and then one part in the second. So I guess technically three parts. So there's a set called the domain, and it contains all the numbers that are the inputs. And we also have a set called the range, and those contain the numbers called the outputs. So domain are the inputs, range are the outputs. And then the second bullet point here, a pairing of inputs with outputs. So a function consists of a pairing of inputs, a pair means two, with outputs, such that each input is paired with exactly one output. So underline that, please. Exactly one. Each input has exactly one output, and we'll discuss what that means momentarily. So here's the example of the gallons of gas and the cost. So here's the input-output table, and it shows the cost varies of regular unleaded gas, or the cost of various amounts of regular unleaded gas from the same pump. Identify the domain and the range. So my domain, we said the definition were the inputs. So we can just do capital D for domain. And I don't want you to go 10 through 17 because that's not true. We're not pumping 10.5 gallons. We're not pumping 11 gallons. We're looking at this for 10 gallons, 12 gallons, 13 gallons, and 17 gallons. And it wouldn't make sense for 10 gallons to have more than one price. That's what I'm talking about previously when I stated that each input has to have exactly one output. Otherwise, it would not make sense if this was the same pump. And my range values, in this case, the outputs are the dollars. So $19.99, $23.99, $25.99, and $33.98. Here's another example, identifying the domain and the range. So my domain are the inputs 0, 1, 2, and 4. And my range happened to be 5, 2, 2, and 1. And you might pause a little bit and say, well, I thought you said they couldn't repeat. Well, the output can repeat. I can have more than one input per output, but I cannot have multiple inputs for the same output. Let me give you an example of what I'm talking about. I have two daughters. So I'm going to phrase it in one way so that you know that it is a function. So if I say to you, and you know the situation, my daughters' names are Emily and Allison. If I say to you, my input is Emily. If you know us, you will know the output has to be exactly, if I ask her who her mom is, you're going to say me. That's input output exactly one relationship. Emily has exactly one mom. If I say to you, I would like to know who is my daughter. Well, you're going to have to know, well, which one am I talking about? Or if I say, my daughter lives in Chicago, you don't know if that's Emily or Allison because I have two children. So if I say, which daughter lives in Chicago, you need more information because I have more than one daughter. So it doesn't always work. It has to be one-to-one. If I say, who is Allison's mom, you know it's exactly me. If I say, where does my daughter live, you have to know which daughter am I talking about. Okay, a mapping diagram. This is another way to represent a function. So a mapping diagram is another way that a function can be represented. And notice that an input, again, can be paired with more than one output. But no, this is what I was talking about before, no input is paired with more than one output. So an output may be paired with more than one input, but an input may not be paired with more than one output. So the 1 goes to the 0, the 2 goes to the 1, the 3 goes to the 2, and so does the 4. Just like here, the 1 went to the 2 and the 2 went to the 2, and that's acceptable. Let's look at this. Tell whether it's a function. 0 goes to 2 and 0 goes to 3. Each input has to go to one output. So this is a no right because of here. And here 0 is only with 0, 1 is only with 2, 4 is only with 8, and 6 is only with 12, so this is a yes. Basically, if your inputs don't repeat, then it's a function. A function may be represented using a rule that relates one variable to another. The input variable is called the independent variable. The independent variable is what you're inputting. Independent, inputting. The output variable is called the dependent variable, because it depends on what value you input. If we look back here and I want to know, well, what is my output of gas? Well, it depends on what your input of gallons was. So independent, dependent. The output, the dollars, depends on how many gallons you put in. So here's another example. We have the verbal rule that says the output is 3 more than the input. Then we can relate it as an equation. Y is the output equals x plus 3, 3 more than the input. And then here we have a table. We are just picking values for our input because they're independent. So we chose 0, 1, 2, 3, and 4. And then the output is 3 more. So 0 plus 3 is 3, 1 plus 3 is 4, etc. So now we're going to make a function table. The domain of the function y equals 2x is 0, 2, 5, 7, and 8. Make a table for this. So I'm going to go x and y. And my inputs, my domains are 0, 2, 5, 7, and 8. And the rule is y equals 2 times x. So my y values, 0 times 2 is 0, 2 times 2 is 4, 2 times 5 is 10, 2 times 7 is 14, and 2 times 8 is 16. So here's my table, and then it says identify the range. So the range are the values 0, 4, 10, 14, and 16. Here they want us to write a rule for the function. So we're trying to figure out what we do to x to get the y, and we have to be able to do the same thing. So it looks to me like we're taking our x and we're adding 2. 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, etc. So x plus 2. Oops. What are we doing to the input to get the output? Y equals x plus 2. Last one. You have $100 saved and you plan to spend $20 each month. Write a rule for the amount saved in dollars as a function of the number of months from now. So the rule is how much we've saved in dollars. It is a function of the number of months from now. So our independent variable is months, and our dependent variable is the amount saved. So y equals, we currently have $100 plus we're going to save $20 per month. So I know that x is the input, that's the independent variable. So it says identify the independent variable. The independent, we'll call it the IV, is the number of months. And the dependent variable, the DV, is the amount saved. Because it depends on how many months you are saving for. And then it says we want the domain and the range. So the domain happens to be what we're inputting. So we're inputting the months. And our months, we can say x is greater than or equal to 0, because we can have 0 months or more. And the range, we're starting out with $100, so y is greater than or equal to 100. So x is greater than or equal to 0 because this is months and we can have 0 months or more. Y is greater than or equal to 100 because we know at least we have $100 if we don't save any more. And then how much will we save altogether 12 months from now? So we'll put this in the rule. Y equals 100 plus 20 times 12. So y equals 100 plus 240. So in a year from now, you will have saved, if you don't spend, $340. Come in with the notes ready to discuss them tomorrow, and we'll do a few more examples of what makes a function and what does not make a function.